Okay, pre-cal, in this video we are still in Unit 8 talking about oblique triangles, and now we're going to shift focus a little bit to something a little easier than the law of sine and cosines, and we're going to look at finding the area of an oblique triangle. Now, from geometry, you're probably all familiar with the typical area formula. The area equals half the base times the height. And that works beautifully when you have a triangle for which you have the height. It also works really well when you have a triangle like this, where one of your right angles can act as the height. But sometimes we can't use this formula. We need something else when we have an oblique triangle or a triangle for which we cannot find the height. So there are three different area formulas you can use depending on which pieces of the triangle you have. So if you have side A and B and the angle in between them, which would be sine of C, or which would be angle C, then you can use this formula right here. Same thing if you have AC and the angle between them, B. If you have two sides and an angle between. That's how these formulas work. So if you have two side measures and the angle between those side measures, so you have side, angle, side defined for the triangle, you can simply take 1/2 times the two sides times the sine of the angle between, and it will give you the area of the triangle. Okay, the other formula we're going to talk about is called Heron's formula, and it was just named after the guy who developed it. So I'm assuming it was a guy. I don't know. I should probably research that before I go blah, blah, blah. Anyway, this formula is going to be used when you don't have any, you guessed it, angle measures. So this is just for use when we have a triangle that doesn't have any angles, because this formula requires that we have at least one angle, and it has to be the angle between the two sides we're given. So what we're going to need the Heron's formula for is finding the area when we only have the side measures. So the first thing we have to do is find S. S represents side A plus side B plus side C divided by 2. And what we do is we use that value along with our side values in the formula. All right, so let's put this into practice. So example 1, we are asked to find the area of a triangle with side measures 3, 7, and 9. So this is a triangle for which we have all sides and no angle. That means that we're going to use Heron's formula. So the first thing I'm going to do is find S, and that is going to be 3 plus 7 plus 9 divided by 2. And what that gives us is 9.5. So when we find the area, we are going to substitute it in. So everywhere you see an S, I would put 9.5. So open parentheses, 9.5 again, minus A. 9.5 minus B. And I don't know that 3 and 7 are A and B. It doesn't matter. They all get multiplied together, so. And then 9.5 minus, oops, not 0.9, 9. And you can just type this into your calculator exactly like that. Everywhere you see parentheses, put parentheses, and what you get for your area is approximately 8.8 units squared. It's in feet. I forgot. That's in feet. So it's feet squared. Don't forget you are using area here, so it is in units squared. Be careful with that. Okay, so example 2, find the area for a triangular lot which has two sides, length 80 meters and 40 meters. So let's call that 40 meters, and let's call this one 80 meters. And we have an included angle measure of 98. Included means it's in between those two values. Okay, so there's our triangular lot. Notice we have side, angle, side. We are looking for the area. So I know that since I have side angle side situation, I can use one of these up here. So I am going to equal this to 1/2 times both of the sides times the sine of the included angle. And I'm just going to type that into my calculator just like that. So 1/2 times 40 times 80 times the sine of 98 gives me approximately 1,584.4 meters squared. Easy peasy, lemon squeezy.